This is Florian from ComSpice, and welcome to our 7th video where we want to run through a complete example A to Z. I have an old Z file for us, and we want to convert this, we want to BIMify this. So we have Advanced in 2021. Let's start a tiny new drawing for us. We have our ComSpice tab available with our CodeMaker. There we just would need to import now our Z file, so we can type in here import. You will find this example file in the installation folder, C program files, Autodesk application plugins bundle, and then we have example project. So there's an old warehouse as a Z file. We can open this up. Let's see how it looks like. So it looks a little bit like this here. So might have been drawn with an older AutoCAD, might have been drawn with any other CAD applications. So we're not quite sure about these sections. We just know that, well, we live in Australia. So obviously they might have used some Australian sections for this. It might take a little bit of a while to trace this even. It's very repetitive, the design, but well, we want to quickly BIMify this, get a couple of parametric section out of this source, and we want to see how Concur behaves. So let's get started here. We can work here with our default compiled file. If you want to specify any project specific or any other files optimized for your environment, because you do a lot of mining, you work with a lot of guys working with some other CAD applications, and you can optimize this or reduce the amount of sections it should use as a comparison to find the right section, then we can optimize this here. Good, in this example we are happy. Let's use the boundary method. Why not? Do we want to have the system line on top? Yeah, why not? Might be maybe also an option. Because it was probably drawn with an older CAD application, we could assume maybe that any fillets or others are not included, just for simplicity. Maybe it's even total SolidWorks file. So we have here our tolerance set to 5%, for example, and then accept it. So next is we have the length over the width ratio, which means that when I have a plate which is, for example, 300 millimeter long and just 100 millimeter wide, we have a ratio of 3. If the plate is 200 millimeter long and 200 millimeter wide, we have a ratio of 1. If we have the plate 200 millimeter long and just 100 millimeter wide, we have a ratio of 2. So this is what is meant with enter the length over the width ratio. This means when we, for instance, have cleats or flat sections which are 500 millimeter long and just 50 millimeter wide, we can specify that these are being turned into flat sections rather than plates or cleats here. And so this gives us a bit the boundary. So this means that we have here then the bottom plate here, for example, that this becomes a plate and this does not become a flat section. It tries to find a flat section for this, but it might be that this bracing here will become a flat sections ideally. So we can here speed up this process a little bit. So hence we have here the option to specify this. Let's leave this with 1, 2, 3. And then we have the next question. So ratio of 3 is okay. So 1, 2, 3. And so this was with our length. So enter the maximum plate thickness. This is here being thought of. So if we have, for instance, solid blocks underneath, or we would have, that not every concrete foundation is being turned into a plate, because we want to consider this as well in our multi-selection. And so we have here the option to specify, okay, plates go up to 20 millimeter. If you have 34 millimeter or something awkward odd, just please leave it, drop it, mark it please with read. I will have to sort it out in a second go. All right, so it gives us a little bit of a first feeling. So the maximum what's available in the workshop, we can enter here as well. I have just left it here by default to 20 mil. Great, so process effects are by layers is very useful. And then we can select here all these, whatever, 100 sections, 400 sections it has found, and processes with a tiny enter. Great. So it will probably find a few sections, some not. Let's see how many it found. So when we, for instance, here select these, okay, we have 2. So it seems to be quite accurate. So 1 solid, 1 beam. We have here, upsala, and solid. Let's see, come on, be nice to me. What kind of beam do we have? 250, you see, good. What do we have here? Also beam. 200 PFC, for us, kind of looks all right. Just maybe here it's a little bit flipped, so we can do this. And for the positioning, quickly mirror this the other way around. Apart from this, it looks actually pretty cool. It has also here, for instance, the section line. The system lines from our section on the top. We have also here the system line on the top, pretty nice. So if you have this as a workflow, this works. It has clearly identified here the base plates as plates in its size. So maybe we still need to correct this a little bit, but well, it is parametric, as we know. Great. So we could then added this afterwards anytime. We have here some read sections, and let's quickly inspect this, what we have here with the read ones. So I'm just copying this thing a little bit out to inspect this a little bit, and looks a little bit that it looks like let me like a PFC, but well, the PFC is would be a little bit thicker. There's the flanges, so would be a little bit more. Let's quickly double check. So let's assume we have maybe heaps amount of trusses with this section. So I kind of have to something it gives me here. I just want to do this a little bit clearer. Yeah. So are you nice to me? Good. Length 250. Okay, maybe it was just not part of my lookup table file. So let's give it a try. And we have here our Concur. Let's specify a little bit of a different file. And we have here all the 214, I think at this point, what is included with Advanced Steel already converted for us. As see in the folder of the section libraries as the profiles. And well, we know that maybe somebody in Australia has used this, and which might be maybe, well, let's see, maybe it's a CC file. So because I think the CC is not included in the default. So let's check this out here. Open this up here. Yes, let's work with boundary on the top. Yes, why not? And give a little bit of a tolerance with it, and then mark it up. Does this work? Oh yes, we actually were right here. And what do we have here? Okay, 250 by 9 it was, so a bit quicker than looking it up. So what does this mean? So because we have quickly tested this with this, we can actually quickly rerun it. And remember, that was here my Aussie CC file. We can here open this up, have here our boundary. Yes, we have it on the top, the system line. We gave it a bit of a tolerance by layer, and then we could theoretically here now select all the other ones and quickly let Concur manage this for us. So Concur actually comes from the conversion of a caterpillar to butterfly, while a solid is like a, well, a tiny butterfly, not like a tiny butterfly, but like a caterpillar, but an Advanced Steel section is like a butterfly. So because it's parametric, it's beautiful, you can change it, it can fly, you can do literally anything with these, you can detail it, it's automized, and so you can, yeah, it's kind of a parametric section. So hence this is how we actually need to choose the name for that. So convert it, and then we are actually pretty happy with it for that. Good. What are the other read ones here? Let's find out what we have here. Just a solid one. No information at all is being part of, and so what do we need to do now? Find it out. Well, maybe the CF are not part of the default. So hence I could actually for the next time compile my own default. And so let's say if you have this CF here, and let's say boundary, yes, maybe give it a little bit of a tolerance maybe, and then let's see if it is nice to me. Select them all. I could actually also do a multi-selection because it would not find the other ones, because it only looks for solids actually. But as a German engineer, I'm a little bit reluctant to solve. Beautiful. And what do we have with the CFs? Let's quickly copy this, quickly compare it, and it's a 100 by 6 flat. Yes, very good. So you see how we have these 400 sections just in a few minutes, how we have converted those. And so these are now parametric. I can now start my automated routines with connection details, running shop drawings, perform changes, performing the alteration, looking after the alteration, designing the alterations, exporting it to Revit, Robot, wherever I want to go. And so it's speeded up the process tremendously. Okay, so this is kind of a full job, how it could work out. So the key is that we have the reference tables optimized, set, but you see it is possible. So thank you for watching. Have a great day.